So yeah, so thanks again. Thanks everyone for joining this first meetup of 2021 for us. This one's going to be focusing on ML and AI on GCP. So just a little agenda and going through everything that we'll go through today. A little housekeeping, some meetup announcement, new little section on GCP news, which is kind of like the guy at the office who reads all the blogs for Google and then just talks about it in the office around coffee. But we don't have that anymore, so let's we kind of wrap this up into the GCP news, give you some ideas of what's going on. Of course, our main we're going to have our main ML section by Adhoc from Google, pop quiz, and we're going to wrap things up. Of course, this is recorded, so you'll be able to need to drop off or anything. We'll share it with everybody at the end. So of course, this is a mixed event, meaning this is GDG Cloud Montreal and Ottawa. So you'll see the team members from Montreal that are all there. So please turn on your webcam so people can see your lovely faces. So myself, Stacy Verano. Everybody can read the slides. So I'm kind of hosting and helping with the rest of the team. Udo is there. Can say hi. Boris is not with us today. Archie, that everybody knows, and Tatiana is there also. I saw her somewhere. And Lilia, I think she was not on yet, but that's your Montreal team. But on the Ottawa team, there's Carlos, who just like he's right there. Just turned off his camera. Bad timing. Thank you. Hi, Carlos. Thanks for joining. And there's Jen also. Who's not there today. So this is your Montreal and your Ottawa team members. If there's anything, any point in time, you can find us through the community pages online. Anything, reach out. Happy to have a discussion around GCP. So what we're all about, like as a recap for like maybe the new attendees, like we're covering the Google Cloud, meaning like the infrastructure piece, like the AI ML, of course. Everything that's serverless, everything that wraps up inside GCP. We also like to do there's like big events like conferences and DevFest that happens where there's a lot of people there. Those things were really cool when we were able to meet people. So we will be back with more in-person fun times, doing what we love on GCP. And we also cover like items from the Google open source pieces. So like stuff like Tecton is going to be covered by Archie a bit later on, or like Kubeflow, Spinnaker, GraphAS, all of those items can be covered. We also do study jams. That's something that's really interesting and can have everybody involved and ramp you up while having fun with the people who love doing GCP. So that kind of covers of what we do. And if I click on the small slide in my screen, it doesn't work. I have to click on the big one. There's other communities for Montreal. There's GDG Montreal, which is like the big, more dev focused community. Covers like Android piece. There's Women Tech Makers, where Uda is the proud representative. And of course, there's us and Google in general. Yes, swag, always good. Excellent. So yeah, the meetup announcement. We'll just go through. One of them is that you can follow us on Twitter. So there's GCP Montreal. So feel free to subscribe. This is where we'll post most of our things. And other few items, there's a call for paper that's always open for Canadian GDG Cloud online events. So if you go at the papercal.io URL, you'll be able to register and set give us an idea of what you want to talk about, and we can gather there. It's a call for paper. So if you're really interested, just post it in there. We'll be able to review, get back to you, and then maybe you'll be part of our speakers. Keeping in mind that we would like to have user stories, so we'd love to see what people are doing with GCP. So let us know, and then you'll be part of the fun of the next meetup. So don't be shy. We don't bite. well, we can't anyway. We can't reach you. So
we would love to hear user stories.
Definitely. So, well, without this, I'm just going to jump on the GCP news side. So there's some big news, meaning like, well, there's the next Google Google Next 21 has been announced for October 12 to 14. I've pasted the link in there also. There's still no official word on the shape it's going to take. Of course, last year was virtual, was over 9 weeks. This year, definitely focus on 3 days. So it might be live, virtual, hybrid. We'll know, and when we know, we'll let you know. So wanted to state that. In terms of new services, and like for the Montreal region, the Google Cloud VMware engine is now available. In Montreal, which means that you can like migrate your stuff like you have on-prem workloads without refactoring them because it's VMware to VMware. But the beauty is that it's a fully managed, stack on the GCP side. So you bring your workloads, but you're dropping the management overhead, which is pretty sweet. So then if you want to learn more, feel free to go to the little link below. Because it's honestly, it's a pretty neat feature. So, and other news, and some of you may already know, we're gonna have a new region in Canada soon. Well, like I don't know when, but it's supposed to be this year. I think COVID kind of like, may derail some plans when it comes to like building and everything and people working together into building a data center or putting things together. So, but still, the target is this year so far. So Toronto will be our next region in Canada. And the beauty of this is then we'll have within the same country disaster recovery, which is awesome. So anything that's financial that requires data residency, then you'll have 2 regions within Canada, which is great. And we'll be able to address those use cases. So same setup as Montreal, 3 region, three region. I love that, 3 zones with distributed for storage and everything else. And then at opening, let's call it that, we'll have the compute engine, app engine, Spanner, BigQuery, like the main services will be up and running, with more to come as things move on. So that's for the news part. Then, if I'm not mistaken, I'll pass it to Archie, who's going to talk about some new stuff on the Kubernetes side with Autopilot.
Fantastic. Thanks, Stacy. Well, I hope we have some GKE users here today, because even if it's a machine learning event, people most probably still using Kubernetes for those things. And I have a quite exciting news for those users. I hope you heard it, but if not, GKE recently announced a new mode of operation, which is called GKE Autopilot. So if we go to the next slide, Stacy, I want to quickly kind of remind how you may be running your Kubernetes today, but like obviously Kubernetes is probably one of the most popular way of running applications today, and people try different ways to deploy Kubernetes. One of them is like kind of do it your own Kubernetes cluster, which involves a lot of knowledge. You need to know architecture, how to deploy, how to provision, networking, patching, security, like day 2 operations. So it's pretty difficult to do on your own, right? And if we go to the next slide, that's where we have the managed experience of Kubernetes with GKE, right? And I think GKE is probably one of the best way of running Kubernetes today. I'm not going to be biased, but that's what the testimony from many users, and it supports 15,000 nodes and all the nice features. And it simplifies and reduces many of the infrastructure tasks that are required for creating and managing Kubernetes cluster that you see on the left side, right? So you kind of managing only the worker nodes. So the control plane is fully managed by Google. And provisioning is automated for you. There's also things like security and network configuration that you may need to also do it on your own. But a lot of stuff has been taken care of by the managed Kubernetes piece. And the nice thing about managed Kubernetes experience with GKE is that you can have many different features, like different types of auto-scaling, different type of security features like sandboxing, workload identity, binary authorization, confidential GKE nodes. So all of these features, something users has been asking, and we've been kind of adding into the GKE. But at the same time, if we go to the next slide, is very difficult to configure all of those things, right? So you kind of need to be an expert on GKE now. So you need to know all those best practices, how to deploy. And then once you learn all of these best practices, then you need to figure out your day 2 operations. You still kind of need to do some upgrades of your worker nodes, at least control plane is taken care of. So recently, Google introduced a new GKE operation mode, which is, as I called GKE Autopilot. So with Autopilot, GKE that manages the entire cluster infrastructure, including control plane and node pools. So before, with the standard mode, you had a control over the nodes. You can see them in your, let's say, in your UI in GCP. But with the Autopilot mode, you're not going to see any more nodes. It's going to be completely transparent for you. You'll just see I have a Kubernetes cluster, and that's it. So all of those things kind of hidden from you. So Autopilot is fully managed Kubernetes cluster that kind of brings all the best things of GKE, like scaling, security, day 2 operations, and it's going to be managed by Google SRE team for you. So you don't have to worry about how to deploy or how to configure and whatnot. So this is kind of thing. And it brings all the Google best practices and security by default. So you don't have to be an expert in GKE. So with Autopilot, users getting hands-off experience of Kubernetes. No need to think about upgrades, size of the nodes, security patches. This is completely invisible for the end user. So this is the next slide that Stacey's showing, is basically telling about the optimized for production. So as I said, before you had to know all of these different features that you need to apply. So right now, all the best practices and all security is kind of done from the get-go, right? So if you just kind of logged into the GCP console, and if you first time you want to deploy GKE, it's going to be deployed with all the best practices for you. So that kind of simplifies your first day, and allows you to focus on your application rather than thinking how to deploy GKE properly and securely. And then when you go to the day 2 operation, obviously the all the upgrades will be handled for you as well. So that's like day 2 and day 1 is covered. Another nice feature of GKE Autopilot, which is kind of improves your resource efficiently, and this is happening kind of out of the box for you. So before you had to think about what size of nodes I need to create so my workloads can run. So this is going to be done automatically for you. So you don't have to think about anything. You just deploy your workloads, and GKE Autopilot automatically configures the size of the nodes that properly fits your workload. And you don't have to pay for the workloads that you're not using. So you can right away start saving on cost from running this operation mode, right? And you would not pay any more for nodes. So before, when you run your standard GKE, you would pay for the nodes, and now you will just pay for the pods that you're running only. So GKE Autopilot from the get-go is GA solution. However, it has some restrictions that you can see here. So you can't SSH into the nodes. You cannot edit the nodes. This is kind of for security posture. And then, some of the functionalities that are available on Kubernetes maybe are not available. So we'll provide the link that you can learn what is the main restrictions with that. And the next slide. All right, cool. So that's GKE Autopilot. Hopefully you can go and try it. Super easy. Just create your GKE cluster and choose the Autopilot mode, and everything will be taken care of for you. All right, and the next news, I want to quickly touch base about the Cloud Run. So Cloud Run, that's another way of deploying application. This is allowing you to deploy serverless containers, right? And I know that we have a lot of users, and we're planning to have I think next event will be about Cloud Run specifically. But there were some recent news around the Cloud Run as well. So you can run a larger containers now. So the limit now is increased to 8 gigabits for RAM and 4 for the CPU. You can do things like bidirectional GPRS streaming, WebSockets, and HTTP2 workloads you can run with the Cloud Run. And for the, if you're running more enterprise workloads, you can connect to the different Google Cloud services and also to the shared VPC now, which is NGA. Next one. All right. So the final news I have for you today is on about Antos. So Antos is Google's cloud-native application modernization platform that lets you run GKE that we just talked about pretty much anywhere. And it provides you enterprise service mesh, Cloud Run, single pane glass for configuration and policies, and also unified logging and monitoring. So if we go to the next slide, as I said, you can deploy GKE on different environments. Of course, you can deploy GKE on Google Cloud, but you can also deploy in Amazon, in Azure as a preview, vSphere, which was like a pretty much standard deployment option if you're deploying on-prem. And you can also attach clusters like OpenShift, EKS, AKS. So the news was that recently they have been added a new option to deploy GKE, which is on bare metal nodes. So if you have, if you don't want to pay for the VMware tax, for example, or if you prefer to run like telco workloads that needs a little bit faster, way of running on bare metal, so you can go with this option. And this is also potentially brings you another variety of, like, if you want to run an OpenStack or Nutanix or any other type of environments that is not covered here. So pretty much you can now run Antos anywhere, as it says. So that's it from my side. I will pass it back to Stacy to ramp it up on the news on the Google side.
On the news, yeah, cool. Yeah, no, thanks, Archie. Yeah, so just continuing on the news and kind of segue on what we just mentioned. This is like the blog news, and one of those, like, there was an announcement, is the developer sandbox. So basically, is that if you want to wrap your head around Antos, like as a developer, you're able basically to run it in a sandbox within your environment. You don't even need a Google account. You can just download stuff and get going. So if you hit the antos-sandbox.dev, you'll have the steps and everything that's required. You see my notes. So basically, yeah, you'll have basically bring you Cloud Shell, Cloud Code, Minikube, and Cloud Build, which is local, which kind of based on Tecton. So you have all those pieces there for you to use, which is great. So continue on in the news, and also in the sandbox and everything. Like, if you wanna, everybody's talking about SRE and tied up to operation, SLI, SLO, SLA. But if you want to wrap your head around like the way things are done and how would things be react inside GCP, if you wanted to apply SRE to like a failure model of something, there's another sandbox, which is the cloud-ops-sandbox.dev, which is the SRE Cloud Operations Sandbox. So basically, like, you have some demo services, you can load generate some stuff, you'll have some SRE recipes / runbook around best practices. So you're able to wrap your head around all those things and go in your SRE journey, doing that on GCP. So continuing on, is just like for some people, like there's a tool, Cloud Domains, that I've been using lately. Just basically, yeah, you're able to register like a domain within GCP, so you buy it there basically. So if you're using Cloud Run with custom domains, you need, I don't know, like stacy.dev, whatever. then I can manage it and apply it straight there and manage it within GCP. So I can manage my zones. I can do like my A records, my CA records for certificate signing. Like if I'm using Let's Encrypt or Google, I can do like pki.goog, and everything that I need, I can set it up there. And everything, it actually brings API and G Cloud command to a DNS service, which is something you don't really see out there. So not a sales pitch, but that's pretty awesome. And also, it's integrating within your GCP billing, so it's like one place to drop everything. So yeah, if you want to have a look, there's the link there, and it's going to be in the recording also. So, but you can just Google the domain piece. Quickly on some of those other things that was out there. There's basically a new YouTube live series, which is Ask Google Cloud. You can binge watch the entire series if you want to, but basically the idea is that you have an expert on a YouTube channel that's going to answer topics, and if you want to ask questions in the future, you just use Twitter with a specific hashtag, which is Ask Google Cloud, and if you're picked up, basically your topic is going to be covered inside of those YouTube live series, which is pretty cool. You're going in another direction directly, and being mindful of time. There's always that thing like, hey, I created that awesome infrastructure, but my boss now said that I need to terraform the entire thing. Would be cool if I could reverse engineer what I did manually and add it in an automated fashion. So actually, there's it's an alpha, it's even beta command, like this is the resource config, which does a bulk export of the resource you created, let's say on project X, but you specify the resource format, which is Terraform. So, which is pretty good, meaning that you created something awesome, maybe a GKE cluster with Cloud Run for Antos, and then you have buckets and everything, or an identity-aware proxy, whatever. And you just say, hey, can I get a Terraform output out of this, please? And this will generate that. It's not magical, but at least from there you can adapt it with variables and make it into a module or something. But you're able to reverse engineer into Terraform what you created manually. So I'm lazy, so I think that's pretty cool. While keeping in the Terraform quickly, there's something that maybe people are not super aware of, something called the private catalog in GCP. Private catalog was usually deployment manager templates in the past. Now it actually supports Terraform, which means that if you've created a piece of Terraform code that people would be able to reuse, you create in private catalog a solution, and your Terraform code is in a bucket, and then the people actually just consumes it and it deploys it for them without the Terraform binary. So it patches everything and it deploys that for them, which is pretty sweet. So I'll skip over just be mindful of time, like the VM manager. Like if anybody wants to do OS patching on GCP, have a look at this. Basically, like for any of your VMs and everything you want to deploy, maintain OS patches up through everything. Have a look at this. You have the links. If you want to reach out on this, feel free. That's my second to last. In the cool post section, there's Priyanka from Google. She's awesome. She's the queen of drawing and video and YouTube's. So she's doing all those sketch notes. You have her website there. Basically explains the solution from Google, but through drawing. So she is, like I said, like she's the queen of sketch note. I think she's basically merging like her passion for drawing and also technology into those sketch notes. So don't be a stranger and go see what she got. And last one, if you ever want to find out which service account are actually not used in your system, that's a pretty good post where there's like with G Cloud and Extra, you're able actually to see like if you have dormant service accounts, so you can actually can them. So in terms of good housekeeping for GCP, and it's a good way to look at that. Yeah, that's actually my last one. I just wanted to like feel free. The chat is there from the until the end. If there's any topic in the future that you would like for us to cover, just drop it in there and we'll just capture them. So go nuts, go free, to do your thing. We'll just capture that. Isn't that way? It's a good way for us to get feedback on topics we could cover in the future. So from now, I'm going to pass it on to Uda, who's going to pick it up from here.
Thank you very much, Stacy. Thank you, Arch, as well. So by now, you know, I'm Huda. I'm co-organizing this meetup in Montreal with the Ottawa team as well. And I'll be helping out our speaker. So by the time our speaker takes over the slide sharing, I want to remind you about a few housekeeping items. Please remember that this is recorded. Be mindful of what you type on the chat. If you have questions, you will be able to write them on the Q&A box. You should have a Q&A box somewhere on the bottom of the screen. And our speaker will be able to answer as many questions as we can by the end of the talk. So stay tuned. And now, without further ado, please welcome our speaker, Advait, on his talk, ML 101 on Google Cloud. Floor is yours.
Thanks a lot. Hopefully you can all see my screen.
Yes.
Yeah, we can.
Okay, great. So today's conversation is really going to touch about the introductory concepts for machine learning capabilities on Google Cloud. By no means am I going to get very deep into technical machine learning concepts, but at the same time, I'm kind of presupposing you guys understand some basic ideas around, you know, what a machine learning model might look like. From a Google Cloud perspective, what we're trying to help our customers and our users with is understanding the different maturity phases that they can have in terms of machine learning and give them the tool set that's required for going through these levels of maturity. So we have a lot of customers who are currently very tactical in their focus with ML. They create simple use cases. They have a decent foundational understanding of machine learning or data wrangling, but they know that they can definitely do more. Then there's people who are focusing on utilizing machine learning in a far more strategic manner. So they're starting to operationalize machine learning in a way that is semi-automated. They're doing a great deal of advanced analytics. They view their models as a source of competitive advantage. And then finally, there are those who use machine learning in a completely transformational way. And in order to be transformational, you need to have a good hygiene and practice around operations when it comes to your machine learning, and establishing a culture of experimentation that is core to machine learning or data science in general. That being said, as you start to get into that more transformative side of the maturity spectrum, you start to notice that there are various different roles, all related to machine learning, that are distinct in terms of the tool sets they need, as well as the skill set that they acquire. You go back a few years, and most of the time, all these people were grouped together just as a data scientist. In reality, there's a lot of different tasks involved. So we have, obviously, on your more non-technical side of things, your product manager, or to some extent your data analysts who are looking at data and trying to make decisions and gather insights. There are data engineers who are more focused about bringing data in and transforming it so it can be used for analysis or for model building. The data scientists who build models themselves, and they have a set of tools that they're comfortable with, like notebook environments. And then you have your ML developers who are taking machine learning models and deploying them inside of applications or other pre-existing software. And then finally, there's the ML engineers who are more so focused on scaling out these models, deploying them, and continuously improving them. So establishing that CI/CD pipeline, but in a machine learning sense. So for each of those, we've identified tool sets, and there's again a bit of a spectrum in terms of your skill set. We have pre-trained APIs and AI solutions, which don't require any ML expertise at all. You can just go and use them as long as you can call an API endpoint. Then what we'll talk about is building custom AI models with AutoML. So using a point-and-click user interface, a no-code approach to building state-of-the-art machine learning models, either it be vision, natural language, or tabular data. And then finally, we provide you the end-to-end core tools that you would require for training a machine learning model, whether it be the notebook environments, the hardware, the compute instances for training and prediction, and accelerators like GPUs or tensor processing unit TPUs. So we'll quickly talk about those APIs or those pre-built solutions. The way you can think about it is we're serving problems in 4 distinct areas. Some are sensory in nature, so sight, either through vision or video analysis, language through translation and natural language classification or processing. Conversation, particularly through things like Dialogflow and our speech-to-text APIs. Some people use them in the call center. Some people are using them for building Google Home or Google Assistant skills. And then finally, with structured or tabular data using AutoML, or for recommendation engines using Recommendations AI. So I want to quickly jump out of the presentation and show you some of those APIs today. So this is the public website for our computer vision. You can go and drop in images here and test things out. So I'm going to load in an image that I took back when traveling was still a thing. This is Kirkjufell, which is a mountain in Iceland. Some of you may recognize it from Game of Thrones. What you're seeing is the output of our computer vision model is first and foremost identifying that this is a landmark and identifying where that landmark is located, the lat lons from the Google Maps API. But then it's able to identify objects. So it's able to see that there's a person in this view, that the person is wearing a hat and some sort of outerwear. In this case, I'm wearing a windbreaker. It's then able to label this, the various different aspects of this image. So obviously there's a lot of sky, there's some clouds, there's water happening with this waterfall, there's a mountain. And as you go in, you can see its confidence about some of these topics becomes less and less, but it's still able to identify interesting things, such as, this being a volcanic landform. Oh, I'm being told that people can't see my screen. Is that correct?
We don't see your face.
Oh, sure, no problem. Sorry about that. Hopefully, there we go.
All good. Everything's good.
Yes, same person in the photo, by the way. Now you can tell that's me in the photo. So hopefully you can see that there's a lot of interesting data that can come out of the machine learning models that are out of the box. A few other things in terms of understanding color. So we actually pull up the hex codes for each of the colors that seems to show up predominantly inside this image. And then finally, we're also identifying if there's any sort of content that might be unsafe to share, whether it be adult content, violent content, racy, or anything medical in nature that might be a little graphic to view. So now you're thinking about software developers who don't necessarily have any machine learning expertise, but they want to use machine learning in their applications. They can use an API like this to gain insights immediately. Same thing with our NLP demo. You can submit any piece of text in there, and what the NLP demo is going to do is it's going to extract, first of all, entities. So entities are typically nouns that are inside of the text. So identifying Google as an organization or Mountain View as a location, and linking to the knowledge articles, in this case from Wikipedia, that has learned these things from. We're also able to identify users, or in this case, we're identifying this, which is a zip code in the United States. So key pieces of text that might be relevant in this context. We're also able to identify the sentiment in relation to entities as well as the full document. So if you're looking at customer reviews, you want to identify what is their sentiment in relation to some of our products or services. You can use this API, again, without any expertise in machine learning. What we're also doing is extracting out the syntax of the sentence. So this is often used for downstream machine learning tasks that can be used for creating custom models. And then finally, also categorizing that. So in this case, this piece of text seemed to be in relation to either the internet or mobile or wireless technology. In this case, because it's talking about Google and Android devices. So now let's progress a little bit further and start talking about more custom models that you can develop on GCP. There's really 3 different ways that you can build custom models. First is BigQuery ML. And the way you want to think about BigQuery ML is it's making machine learning accessible as much as possible to a broader range of people. So either data scientists and machine learning developers who are comfortable building models, or data analysts who may be more used to churning through data or looking at tabular data and likely know a certain amount of SQL. So with BigQuery ML inside of your data warehouse environment, inside of BigQuery, you can write 5 lines of standard SQL that'll generate a model. You can select some of the hyperparameters of that model and select the data in which it's going to be used to either train or to predict an output. So as you think about simplifying machine learning or making it more accessible to the masses, this is one of the ways that you can do it. But at the same time, by maintaining all the compute inside of BigQuery, you're making sure that people are not making copies of your data, taking them outside of your data storage environment and allowing that data to get stale. You're also establishing good practices in terms of how you use your data for ad hoc analysis on an ongoing basis. So to date, BigQuery ML supports various different model types. But firstly, in classification, we have different model types. In regression, we have various different model types that we support. We also have unsupervised models for k-means clustering or for time series analysis, as well as building matrix factorization models, which are typically used for recommendation engines. One of the interesting aspects of BigQuery ML is interoperability with various different model formats. So you can use an AutoML model that you've developed inside of AutoML. You can also import and export in TensorFlow models that you've built from scratch and utilize that inside of a BigQuery environment. So as a data scientist or a machine learning developer, you can possibly build a custom bespoke model, deploy it into BigQuery or BigQuery ML, and allow your data analysts who know how to use SQL to consume that model in an ad hoc fashion without having to worry about training them up or upskilling them and understanding how a Keras or a TensorFlow model would otherwise look like. The next layer of sophistication here is around AutoML. So with AutoML, I mentioned earlier, you have a point-and-click interface, but it really simplifies a lot of the workflow that a machine learning engineer or a data scientist would have otherwise gone through. Typically, they'll load in data, and there's a lot of steps that are involved before they can even train up or deploy a model. There's a lot of data preparation and cleansing. Oftentimes, data is messy and has a lot of errors in it. Next, they're oftentimes engineering brand new features using that data to improve the quality of the prediction of the model. And then finally, they have a large number of model architectures that they can select from, and each one of those architectures has its own parameters that require tuning. So you iterate this across the amount of time that it takes to do this, and then on top of that, the amount of compute resources and the cost of doing this. This can be quite a cumbersome and time-consuming task that prevents you from getting insights or value from machine learning in a timely manner. So with AutoML, what we're really aiming to do is remove a lot of that complexity. The goal is to load in your data, explore it quickly, analyze to make sure there's no anomalies, and then offset a lot of that complexity and experimentation to AutoML to engineer features, cleanse your data, select the appropriate model architectures, hyperparameter tune, possibly ensemble your models together, and then finally spit out the evaluation metrics and criteria for you to see how well that model is performing. And through the click of a single button, then deploy it to a scalable endpoint. So you now have an API that you can call to serve inside of a production application. So underneath the hood, Google is searching through its model zoo of various different model types. We're constantly adding to this based off of our research, either in Google Brain or inside of DeepMind. So you're always going to get a model that is going to be near state-of-the-art in its performance. Inside of AutoML, we're able to deal with a large number of common data challenges, so numeric data, textual data, categorical data, as well as building in guardrails for common problems, such as imbalances in your data set that may result in overweighting of a specific class or missing values that need to be imputed in and implied based off of other values inside of your data set. Now, the thing that really makes AutoML sophisticated is underneath the hood. What we're doing is a lot of techniques that have come from our research inside of Google Brain. One of those research approaches is neural architecture search, or NAS. So what neural architecture search is doing is it's using a reinforcement-based learning algorithm to identify what the best quality architecture and best hyperparameters are. So rather than doing a grid search of every permutation and combination of model types and hyperparameters, we're able to drastically increase the speed in which we can converge towards an optimal model and reuse far less compute in order to do that. Now, in terms of what kind of results have we gotten, oftentimes what we'll do is we'll take an AutoML model and we'll chuck it at a Kaggle competition. So Kaggle is a platform that Google purchased a few years ago. It's where people will go to do data science challenges to see how well they can best their competition in building a model. In this case, what we were doing is the Mercari price suggestion challenge, where you're trying to identify what the optimal price would be to drive demand. In this case, after an hour, what we were finding is AutoML was able to get into the top 1,000 ranks. After 12 hours, you're getting into the top 400. And after about 24 hours, we're getting into the top 100 rankings of a Kaggle competition. Now, for those of you who have never done a Kaggle competition before, what you'll find is the person who comes first and the person who comes 1,000th, oftentimes the amount of error difference inside of those two is fractional in nature. The difference is not particularly large. So when you start thinking about the practical aspect of AutoML and deploying models and being able to allocate your time and resources effectively, you're able to get something that's extremely serviceable with very little time spent and with no machine learning expertise whatsoever. We're also able to expand out AutoML not only in tabular data, but also with with NLP models, so building your own custom NLP model for classification, sentiment analysis, or entity extraction. And the same thing then also applies in computer vision, where you can now classify content or screens, detect objects inside of them, and then do image segmentation. Oftentimes that's used for autonomous vehicle use cases. So now, what is the experience of using AutoML? What I've done here is I've loaded in the data set from BigQuery. Once you load it in, it shows you the various column names and the data types. If you want to make corrections to these data types, you can click and change from numeric to categorical. You can also nullify one of these fields and say that it's possible to have no real value inside of one of these columns. We also spit out some feature statistics about the distribution and the number of missing values. And then finally, you identify what the target variable is, or the target column, the one that you want to predict. And then finally, you click the train button. It's really as simple as that. It's review your data, click a button, allow it to train. After some time, once it's done training, you'll go into the evaluation section and it'll show you your common model statistics. In this case, this is a classification model, so we're able to see things like your accuracy and ROC curves. As you scroll further below, you see a confusion matrix to see how well this model is classifying text or classifying the test and validation data sets. And then finally, we're also able to see feature importance, which gives you a little bit more in terms of explainability about your model to explain why it's making the decisions the way it is. In order to deploy, you go to test and use. And I've already deployed this model, but there's usually just a button here. You click on it and it'll deploy to an endpoint. You're able to point to a BigQuery data set or make changes to your values directly inside of the user interface to test a brand new value and get a prediction inside of the user interface. So this model, which is about 323 megabytes in size, was trained over the course of only about 16 node hours. 16 node hours took about 3 hours to train because we had multiple nodes working in parallel. And inside of that time, it was able to explore through various different model architectures and give me what it felt was the best quality model for the data set that I had trained it. The same thing applies in NLP. You're able to load in text-based data, click on a value, and simply drag and drop and label some of the text inside of that data set. And the same thing applies with computer vision. In this case, what I have is a data set of microscopes that are trying to identify various different aspects of malaria. In this case, I've taken an image, I've gone in, and you simply just drag and drop an anomaly that you want the model to be able to detect, and you label it. So you can see a very simple workflow, one that has no technical expertise required, no machine learning expertise required, and also no development expertise required. It's all point and click or drag and drop in nature. The final aspect that we'll quickly talk about is our Cloud AI platform. So now we're talking about custom model development. This is where you're a data scientist who knows machine learning and wants to build something from scratch. So we give you our unified Cloud AI platform, where not only can you have the tools like your notebook environments to build models, but it's also side by side with your AutoML models. So you can compare the two and see, does AutoML establish a good baseline for your data set, or do you need to invest the time to create something from scratch on your own? We provide simplified APIs, a user interface to interact with your data, as well as an SDK to simply create and deploy your models, as well as your common security requirements that you would have in terms of giving access through VPC service control, customer managed encryption keys, and obviously IAM access rights as well. Today, we provide pre-configured environments that typically will have the common machine learning frameworks that you would use. So NumPy, SciPy, TensorFlow, Keras, PyTorch, XGBoost, scikit-learn. These are all provided out of the box as deep learning environments that you can use underlying your notebook environment. So these are all tools and frameworks that data scientists are already comfortable with. There's no proprietary technology here. We're all focused on open source or open frameworks when it comes to our Cloud AI platform. One of the other benefits of Cloud AI platform is its ability in supporting you with hyperparameter tuning or optimization. For those of you who have built machine learning models, or for those of you who haven't, oftentimes you're testing around different parameter configurations for your model to get the best quality. Typically, you'll do some level, or in the olden days, you would do a random search approach where you're just testing various different permutations and combinations. Later on, we tried Bayesian approaches, and now we're also looking at multi-banded, which is somewhat of a reinforcement approach to hyperparameter tuning. What Google Cloud provides is Cloud Vizier, which is a combination of various approaches. And what we find is the amount of time and compute required to get an optimal resolution is drastically better using Cloud Vizier than it would have been just randomly searching through all the various combinations of model architectures. We're also able to provide explainability in models, especially in regulated industries. This is becoming more and more a topic of discussion. So whether it be a differentiable or non-differentiable model, meaning a tree-based model like XGBoost or a neural network-based model in TensorFlow, you're able to understand the reason for the model making decisions based off of feature importance. And that works not only with tabular data, but as well as with NLP data and with image data. So in this case, we're able to identify the pixels inside the image that resulted in the greatest confidence in a specific classification output. So you can start to understand how your models are making decisions, and you have a bit more traceability in your model's own thinking. As I showed you inside of AutoML, even with custom models, we have continuous evaluation of your models, tracking for drift or skew inside of your models over time to trigger retraining jobs, as well as giving you evaluation criteria from your training jobs to say how well is it performing based off of common statistics like precision, recall, and accuracy, and tools like confusion matrices. And then finally, one of the more up and coming topics these days is providing simplified machine learning operations, or ML ops, through pipelining. So we have managed pipeline offerings where the direction is typically to take each step inside of that pipeline, containerize it as a function. Those functions that are deployed onto our cloud container registry and executed as a DAG or a acyclic graph, directed acyclic graph. Inside of each of these steps, you can also offload some of the processing to serverless compute. So whether it be data extraction and transformation inside of BigQuery, training and prediction happening inside a cloud AI platform, transformations using data flow, and then finally storage of artifacts and metadata inside of cloud storage. Each piece of the pieces of these composable pipelines can be pieced together and then use serverless offerings on Google Cloud in the way that you feel is going to be best suited for your internal pipelines. So in summary, and this is obviously a very high level conversation about the capabilities of machine learning on Google Cloud, what we're focused on doing is providing you the technology and the capabilities depending on where you are. So not all of the models need to live on cloud. Many of them can be exported out and deployed on-prem or at the edge. We're bringing in our leading expertise in machine learning and AI and pushing our data and product quality based off of that expertise, and especially using technologies that Google uses internally for machine learning development, things like Cloud Vizier, things like our neural architecture search, were internal Google products and capabilities that were now made public for Cloud AI Platform. We're also streamlining the process of deploying and managing models through MLOps tooling. And then finally, bringing in the greatest of our AI research inside of things like AutoML, where we're constantly adding brand new machine learning capabilities. So with that in mind, I want to make sure we leave some time for questions, and then also make sure we have some time for our pop quiz. And I believe there's going to be some prizes shared.
Right.
So without further ado, I think we can jump into some questions.
Thank you very much, Advait. This was a very thorough presentation of all the tools. I think we have one question to start with. So again, please feel free to ask your questions on the Q&A box. Our first question is from Nadia, who's asking if you have any recommendations or resources for beginners or just for getting started, like books or web links.
Okay, yeah. So I think there's two ways to think about it. There's utter beginners who don't necessarily know anything about machine learning. There's a lot of Coursera courses that I think are great in terms of learning some of those concepts. Historically, Andrew Ng's Coursera course at Stanford, I believe it's Stanford, is often referenced. So that's a good starting point. There's maybe some linear algebra and some calculus you may need to brush off if you haven't done machine learning or any math in a while. The other approach that I would also recommend is to go on to the Machine Learning Engineer exam cert, the GCP cert. And there's a lot of courses that are pointed out there that I think are good introductory as well as advanced concepts that will get you comfortable with GCP, especially with TensorFlow related model development and some best practices in general that are machine learning oriented.
Right. Another question. So Mateus is asking how to monitor an AI on GCP.
Mm-hmm. And we're adding more of this tooling day by day, especially for Cloud AI Platform, to help with some of these challenges. One of the capabilities that will be that lives in some nascent stage today, but will be coming up more so in the coming weeks, is continuous monitoring of models. So as I showed in the presentation, effectively you'll have an endpoint where you define the model metrics that you want to be tracking, and you want to make sure that your model isn't drifting over time, or the distribution of your data that you're using to train your model is not shifting over time. So today there's some manual development you would have to use. So TensorFlow Extended, which is a framework used for creating machine learning pipelines, has something called TensorFlow Model Evaluator, where you can define the model metrics that you want to track over time. But in the future, we'll be going towards a little more hands-off approach where GCP will track some of these metrics for you, as long as it's deployed to a GCP endpoint. I'm personally not a Pinot Grigio fan. I prefer Pinot Gris. While they're the same grape, there's stylistic differences. So, Stacy, that's my answer.
I love it. Thank you.
Before we move on to the Kahoot and the actual questions and prizes, how can our attendees contact you if they have if they want to reach out? Are you on Twitter?
Sure.
Are you?
I think one more question. Sorry, from the.
Sorry, I just saw it. Okay, it just popped up.
And I'll get to Fernando's question, but my social media game is quite weak, so you can find me on LinkedIn. I'm not on Twitter. I'm not on Instagram. I might be on Friendster and MySpace, but unfortunately, LinkedIn is probably the easiest way to find me.
Perfect.
In terms of the differences between an ML developer and an ML engineer, now I would say a lot of these roles are not well defined or agreed upon in industry. This is Google's perspective on this, which is an ML developer will build applications. So they'll embed machine learning models inside of an application. A good example of this might be, if you have an app where you're using speech to text in a mobile application, that would be what an ML developer would do. An ML engineer is more focused on the CI/CD pipelines and the ML ops surrounding a machine learning model after the model has been developed and deployed into production.
Carlos joined the new company recently. What are you doing there? Are you ML developer or ML engineer?
I think I'm everything. Data scientist, ML developer.
That's what I thought.
Kind of hardware specialist going down and profiling GPU. It's kind of intense.
Huda, how about you? I think you also like working in the ML space.
Similar.
Similar.
Yeah, pretty much a little bit of everything. Nothing was defined when I started. I guess we have more structured definitions now. So I might reconsider, but
yeah, I don't know. Maybe you, Advait, saw what's happening in the industry. Is it all in one, or there's like different teams? And
it really depends on the size of your team. I say if you go back a few years, or if you work in a startup, oftentimes you're all of the above, which is unfortunate. I'm sure your day is a bit stressful and you're learning a whole lot. As you start to get into that transformative range of machine learning, where you have to do so much, especially with the ML ops side of things, it becomes untenable for you to take on all those roles. So I think it makes sense for you to define distinct roles in terms of who trains the models, who transforms and ingests the data, who deploys the application, and who maintains the CI/CD pipelines to continuously improve it. So I think that's where a lot of people want to get to, but there's maybe a little bit of maturity that's required before you get there, and team size is required to reach that kind of capability as well.
Yeah, and the thing is, today we want to just kind of open the tap, right, of ML. So it was really one-on-one, just like overview. We were hoping in the future sessions to cover like more specific topics, and we're actually asking you in the survey today, what do you want to hear? Like we had some ideas about MLOps, about AutoML, maybe some hands-on. So obviously there's a lot of interest around ML, and GCP also have very interesting solutions around that. So, but we can also do more into open source, side of the things like TensorFlow and Keras and whatnot.
I see one Kubeflow question showing up.
Yeah. So yeah, please let us know what you're interested, and hopefully we can do another 2-3 events around machine learning during this year. And I hope Advait will help us maybe on one of the sessions, one more. So let us know. Yeah, Huda, you wanna say anything before we switch to Carlos to the Kahoot?
Well, honestly, just thank you to our speakers. And thank you to the attendants. I guess we were a little bit short on time, and then we want to maybe next time have a longer time and more questions to be answered. But yeah, please, Carlos, you can take it over from here.
Thanks, Advait. We hope we'll see you more in our events.
Thanks, Advait. Let's get it, guys. Thanks, Advait. Thank you. Okay, thank you, Huda. Everyone else, so let's get started. We are starting right now. Let's move forward to one of the most fun parts of the event. It's the pop quiz. I'm Carlos, data scientist based in Ottawa. We are asking you to prepare your phones, okay, or laptops. Install the Kahoot app. Kahoot, K-A-H-O-O-T. I probably have been used that before in other online events and conferences. You need a web browser where you can put the code that we will provide, okay, for you to join the Kahoot link. One observation, note that we all are granting prizes to participants who are based in Montreal and Ottawa, you know, just because of the mailing service. We're not able to go to Australia or to Brazil yet. The winner of the quiz will receive, what will we receive, the winner of the quiz?
It's actually supposed to be on a slide if Stacy or Huda can share. We prepared a couple of nice presents this time.
What a special prize. That's even a surprise for me.
Actually, can you refresh your screen? I think it's one of the missing.
Yeah, really? Okay. Let me, oh, there's a hat. So.
Yeah, no hat. We added a hat already. So we have first place, it's going to be Google TV, and then second place is Kubernetes hat, and then mask. So pretty cool prizes.
Sweet, sweet. Cool. Second place, we're also going to have the SAQ card for booze.
Oh, okay, so we have SAP.
Like booze. Okay, cool. Let me set up in here. Let me share my screen first.
All right, good luck, everybody.
You probably can see me.
You need to run the, yeah.
Loading game pin. Let's see. So it's 9093579.
So we have
9093579.
Carlos, can I join myself, or it's only for people who participate?
Well, if you win, you have to send to my home just because I participate.
I'm sure if Advait play, he's gonna win the first place. So hopefully he's not gonna join.
If he wins, goes to Huda. A few more minutes to join. Now that
it's only 16 people. We need more. We have 40 participants. So let's wait a few more minutes just to make sure people may be installing the app.
Yeah, even though if you are not able to win the prize, just play for fun, you know?
At least the questions will be around ML, so hopefully people learn something from Advait so they can know the answers. Somebody dropped. We had 18 and 17. Somebody gets scared, maybe, like ML.
Game pin 9093579. Shall we get started? We can. Those ones who will be joining later, we'll catch on the way. Shall we?
I think, yeah, we can go ahead. It's only 18 people, so I'm surprised. Why other people don't want to participate. So we're only going to show the 3 winners at the end, right? So don't worry. Yeah. Just you can join it. It's totally...
Okay.
Yeah.
Let's get started. ML on GCP. Prepare your fingers. Be quick. 7 question. What's the Google Cloud Hyperparameter Tuning service called? Hypertune, Bezier, Katib, Autotuner. Whoa, that was quite a split, eh? Bezier. Which ML task does AutoML not support? Table of data, language, vision, clustering. Good.
How can we...
That is a winner,
okay.
Right?
Yeah.
Almost a winner. Which AI tool always allows you to create models using standard SQL? AutoML, BigQuery ML, AI platform, TensorFlow. There you go.
That was easy, I think.
Gap going up, Ilas and Neka. You can use AutoML from inside your BigQuery data warehouse. True or false? There you go, true. Neka going up. Penultimate question. AutoML will do future engineering for you. True or false? There you go, true. Ilias going up. Penultimate now. Explainable AI does not work on image data. True or false? My bet's false. Yeah. Oh, bit of a changing here. Last question. That's quick, eh? AI platform supports PyTorch. True or false?
Great.
Let's see the podium now. Naka third. Gab second. And the winner is Ilias.
Ooh, somebody got Google TV today.
Someone got, yeah.
Now I'm sure, and I need to figure out that, especially the people who win the first place. Can you make sure they fill up the survey now? So Stacy, can you please put the slide?
Ilias, Gab, yeah.
Well, the survey.
Yeah, please.
Congrats,
all right,
guys.
so we're close to ramp up. I don't know who is gonna ramp up today with us, Stacy.
Well, listen, everyone, thank you for being here, and we really, really would like to have you fill out the form. Either if you're in Canada or outside of Canada, we want to hear back. We want to hear from you. Understand if this format is good, if the timing is good. We have questions for all the sections. Please fill out our forms. And yeah, I mean, I guess Stacy, you open. I'll let you close the session for everyone.
All right. No, thanks, Udif. Thanks for everybody who attended this first meetup of 2021. Hopefully, we'll be back soon with more fun topics around GCP. And thanks everybody. Thanks Archie. Thanks Huda. Thanks Carlos. Advite. Everybody who helped set this up. It's never easy doing everything remote, but we kind of always figure out and pull it off. So hope you enjoyed the event. Feel free to leave comments. Please fill in the survey so we can even be better and more awesome next time. And on those words, I think we'll wrap things up. So thanks everyone, and have a great rest of the day.
Thank you.
Thank
We're
you.
going to post the next event
Bye.
shortly, hopefully.
Yes, let's do it.
Thank you, everyone. Merci.
Bye.
Bye-bye.